Hi, I welcome all of you in my channel and in this video in which I am going to solve this question. It's a two sample z-test with the two tails. Initially, I will formulate a hypothesis, then z-naught or z-statistic followed by the p-value. Then to decide about rejection of the hypothesis, I will check the rejection criteria. After that, I will interpret the results and make the conclusion based upon the technical statement. If the question arises that why I have selected a z-test to perform this question, so it is clear to you people that the standard deviation of machine 1 is equal to sigma 1 0.015 and standard deviation of machine 2 0.018 has been provided, and whenever the standard deviations have been provided to us of the populations, we will always use the z-test. In this question, we are going to compare the means of both machine 1 and machine 2, and the question statement says that the quality engineering suspects that both machines fill the same net volume whether or not this is volume is 16 ounces. So based upon this sentence, we know that we formulate the hypothesis of two tails. Let's start with the hypothesis formulation. Before the hypothesis formulation, please write what is mu1 and mu2. I have taken here mu1, basically mu is used for the mean. So mu1 is the mean filling volume of machine 1 and mu2 is the mean filling volume of machine 2. So we have null hypothesis and alternate hypothesis. The null hypothesis is represented by H0 and alternate is H1. In the null hypothesis, please remember that we always keep our equality sign in null hypothesis. We say that the mean of both machines are equal or mean filling rate of both machines are equal. Whereas in alternate hypothesis, the thing which we want to prove we always keep in the alternate hypothesis. So we say that the mean filling rate of machine 1 is not equal to machine filling rate of machine 2. The next thing we want to prove is our test statistic z0. I will write the formula for the z0 and then I will put all of the values in the formula. I am following the book Design and Analysis of Experiments by Montgomery, and in that you can see we have two samples. The z0, this is the z0 formula, and associated with this case that mu1 is not equal to mu2, we have our rejection criteria. Modulus of the z0 is greater than z alpha by 2. If this is satisfied, we reject our null hypothesis, and the calculation of the formula for the calculation of the p-value is p is equal to 1 minus probability associated with the modulus of z0. We will go through all this. Let me pick this formula from here. So in this formula we need y1 bar, that is the mean of the sample 1 machine, y2 bars the mean of the sample that has been collected from machine 2, n1 and n2 are the two sample sizes, and sigma 1 square sigma 2 square are the standard deviations of both the samples. So in order to calculate the mean of the sample 1, the standard way of writing is that you will have to write only first two values initially. That is, you can say from the book I am telling you 16.03 and 16.01. so look at there please, 16.03 and 16.01. I just wrote one there, and then write the plus sign, then after that three dots and then again plus. After that you will have to write the last digit. So 15.99 is the last value of this sample. So in this way we write it technically, because when we write all of the values it's too much time consuming, and then divided by 10 we got 16.015. Similarly we do it for the sample 2. The number of observation in sample 1 are 10 and also in the sample 2 are 10. Now we will calculate the variance. The formula for the variance is that xi minus x bar, where xi is the individual value. So we will subtract each value, just like 16.03 minus 16.015 and 16.01 minus 16.015. Likewise till the last value, that's 15.99 minus 16.015, and then we will take the square of all these 10 values divided by 10 minus 1, because 10 is the sample size. Likewise, I have written the first observation 16.03 minus 16.015. This is the mean value, this one. Bracket close here, then plus, then three dots, then plus, then the last value 15.99 minus 16.015 whole square. But you will have to do the same for all of the observations. in the calculator. Then we have after solving, I got the standard variance for the sample 1 is 0.015, whereas the variance of the second sample has been solved in a similar way and we got 0.018. After putting all of the values that have been calculated, we got Z naught is equal to 1.35. Now we will talk about rejection criteria. The rejection criteria for a two tail and two sample t-test is modulus of the Z naught is greater than Z alpha by 2. We got Z naught value equal to 1.35 and that will be greater than Z alpha by 2. Now alpha is equal to 5% or 0.05. For a two tail we divide alpha by 2, so we got 0.025.